In this equation, we have sulfuric acid and sodium phosphate. This is a double displacement reaction. And we're going to use a little trick here to count the atoms up. We see we have this SO4. This is a sulfate ion. We have it here. It stays together. We have one here. We're going to count that as just one item. Same for the phosphate. We have the PO4 here and here. We'll count it as one item. That makes the balancing much more manageable for these double displacement reactions. Let's count the atoms up. 2 hydrogen atoms, SO4, the sulfate, we have 1, 3 sodiums, phosphate, we have 1 of those. On the product side, 3 hydrogens, 1 sulfate, 2 sodiums, and 1 phosphate. Let's do it this way. We can leave the hydrogens till last. Let's get this to an even number. That'll make it a lot easier to balance. So I'm going to double the sodiums. I'm going to put a 2 in front of the sodium phosphate. That'll make this an even number. I have 3 times 2. That'll give me 6 of these sodiums. That's an even number, be easier to work with. And then phosphate, 1 times 2. I have 2 of those. On the product side, we could take and put a 3 in front of the sodium sulfate. 2 times 3. That gives us 6 sodium atoms. Those are balanced. And then the sulfate, we have 1 times 3. That'll give us 3 of those. At this point, let's balance the sulfates. We could put a 3 in front of the H2SO4, 1 times 3. That'll give us 3 of those. And then for the hydrogens, 2 times 3, that'll give us 6. And we're almost done, because if we put a 2 in front of the phosphoric acid, 3 times 2, that equals 6. 1 phosphate times 2, that'll give us 2 of those. And we're done. This equation is balanced. So you can see how counting these polyatomic ions, if you have it on both sides, sulfate here, or a phosphate and a phosphate, that makes it a lot easier to count the atoms up and then to balance the equation. That's it. This is the balanced equation for H2SO4 plus Na3PO4. And this is Dr. B. Thanks for watching.